This meeting is being recorded.
In problem 10 from chapter 13, we are asked to predict the major product or products for each of these following reactions. And reactions in examples A through F are all examples of acid cleavage type reactions. So that's what we're going to see. We have our ethers and then an excess of HBr and heat in example A here. So the oxygen atom is connected to each of these carbon atoms here, and they are sp3 hybridized. So when treated with hydrobromic acid, we expect this to cleave each of these CO bonds and replace them with CBr bonds. So what we expect to have our product looking like is, since this is a symmetrical starting ether, the result will be two alkyl bromides that are identical. So they would look something like this. And we would also have water as a product. So we'll have rather two of these alkyl bromides and then water. So that's our predicted products for reaction A. So we'll see the same thing happen or similar thing may happen in compound B here. When treated with excess HI and heat, these two carbon-oxygen bonds will be cleaved. And again, we have a symmetric starting material. So our product will give this following diiodide. And water as well. So we'll see again this trend continue when we have an sp3 hybridized carbon like this one here. This CO bond will be cleaved and replaced with a CBr bond, but the other CO bonds within the benzene ring will not be cleaved because it is sp2 hybridized, and it's not suitable for either SN1 or SN2 mechanisms. So what will happen is our products that result will be a phenol and this ethyl bromide as well. So in part D here, again, we see only this carbon that is sp3 hybridized within this ether. So in this structure, when treated with excess HI and heat, that CO bond will be cleaved and replaced with, instead of CBr, we'll have CI instead. So the product will be, again, something where that benzene ring, that sp2 hybridized carbon is not cleaved, and we end up with an OH there. And then the rest of the cyclic structure becomes a chain and iodine on the end. For compound E, we will see cleavage at both of these sites here, and we will end up with, in our product, a racemic mixture of this diiodide structure when we react, again, this cyclic ether with excess HI and heat. So last but not least, we have this structure here. So we see two sp3 hybridized carbon atoms. So we treat this with excess HBr and heat. So we would end up with this first product. And we also get this ethyl bromide, cyclohexyl bromide, was our first structure, and water. Oh, and we forgot water is a product here as well.